Hey guys, we will be continuing our lectures on springs, and we will be taking our topic of Hooke's law again, and we will see how we move forward with that. So we know that Hooke's law is given by F is directly proportional to extension. The more you apply the force on the spring, the more it extends. So that is, guys, that is Hooke's law. Now, you know from your mathematics that if you have to remove this proportionality sign right here, what you do is you introduce a constant value and change this proportionality sign to n is equals to sign. So let's see, F is equals to K times E. This is our formula. I remove the proportionality constant and put n is equals to sign here, and I had to introduce a constant value. This is called the constant. This is the constant in this case. Alright? Now remember, before I tell you what this constant is, remember that this constant K is the internal property of a substance or of a material. What do I mean by internal property of a material? I mean that every material has a different K. Steel will have its own K, aluminium would have its own K, and let's say lead will have its own K, iron will have its own K. No matter what the size is, what the weight is, what the thickness is, K depends on the material. If it's a spring, if there are two springs, let's say one is a thinner one and one is a thicker one, but both of them are made up of, say, iron. Okay, you can't see, but yeah, here. Both of them are, let's say, made of iron. So the K value, the value of K value will be the same for both, because they depend, the value of K depends on the material. If both of them are made of the same material, then the K value for both of them would be the same. So we have different charts for these values. So whenever we'll be doing a question, we'll see how we find out the value of K, and it will be constant for different materials. So, and they don't change. It's like mass, it's like density, it's an internal property, it doesn't change, right? It depends on the material, not like mass exactly, but like density, I'm sorry, but like density is same for iron, for no matter what the size of the object is, whatever it is, it's the same for a material. So that is the K value. But what is the K value? The K value is also known as the stiffness of a spring. Now let's see how I could just say it like that, you know, because in physics we're not allowed to say anything like that without proving it. So let's see, F is equals to KE. This is our formula, but this is the force. This, as I said, apparently is the stiffness, and this is the extension. Now let's see, if I just switch the formula and make K the subject, this would become K is equals to F, and this would come here, K is equals to FE. Now let's just compare the situation. I call this the stiffness of the spring. Let's say there are two values of K. One value of K is 4. The other value of K is 2. Alright? Let's just put it here. Let's just put 4 here. 4 is equals to F over E, and 2 is equals to F over E. Now you can see that this is simply a ratio of the force and extension. You were simply saying, let's say, it's like a question. It's like, what is the extension when I apply a force? Let's say, if you apply a force of 2 newtons, the extension is 1. In this case, it will give me an answer of 2. If I apply a force of 2 newtons, the extension is 1. 2 divided by 1 will give me 2. Alright? In this case, if I say, because I have to make the answer 4, the simplest way to make the answer 4 is to say that if I apply a force of 4 newtons, I get an extension of 1. So you can see 4 divided by 1 is 4. Now if you analyze what have I done here, I have tried to make you imagine how the stiffness is working. You can see that I call this stiffness. When the stiffness has a greater value, here it had a greater value compared to this, you can see that the force was 4 newtons and the extension was 1 meter. That means that you are pulling it with 4 newtons to get it to 1 meters, right? But when the stiffness was less, let's say it was 2, you applied a force of 2 newtons and you got an extension of 1 meters. Earlier, you had to apply a force of 4 newtons to get an extension of 1 meter. Now, because of a lesser K value, a lesser force can give you an extension of 1 meters. That means the spring is softer now. And earlier it was harder, it was tough because you had to apply more force to get an extension of 1 meters. Now you apply 2 newtons and you get an extension of 1. So you can see that this value here is actually the stiffness. It is telling you how hard the spring is, how much force you need to apply to get the extension. Let's say if a K value is 20, this would mean 20 newtons over 1 meter. So you would mean, because you know K is F over E, so let's just say F is 20 and E is 1. That way we can make K is equals to 20 if the value of K is 20. So you can see that in that case, since the K is higher, that would mean that you would need to apply a force of 20 newtons to extend it for 1 meter. So you can see it's tougher now. You have to apply a lot of force for just an extension of 1 meters. So this spring with a K of 20 newton per meter, you can see the units. It would be Newton divided by meter. An extension of a stiffness of 20 newton meter means that it will be a harder spring compared to a stiffness of 2 newton per meter. This spring would be a softer spring. So this is what your K tells you. So for every spring, you can just by looking at the spring, you can simply judge it. Let's say I have 2 springs here. Say this is my yellow spring here. Let's say it's made of aluminum. I'm just taking random values. It has a stiffness of 2.3. And here's my blue spring. And it has a stiffness of 1.4 newtons per meter, both of them. Now let's say I am applying a force of 10 newtons to both. Now just imagine, first of all, you should be able to imagine now that which spring would extend more with a force of 10 newtons. You should be able to imagine now. Because the stiffness of this one is lesser than this one, you can safely say that this is a softer spring. And it would be easier to extend this spring compared to this one. This one would take in more force because it's a harder spring. So let's say I predict that the spring P, let's say this is made up of iron, that iron will give me more extension, will extend more. So let's see, our formula is simply F is equals to K times E. Force is equals to K times extension. Now we have to find out the extension. So just simply put in the values. 10 is equals to, for let's say first we're doing it for aluminum, 2.3 times extension. Alright, so E is equals to 10 divided by 2.3. Now this will give me something like around about approximately something like 4.2 or something. Alright, this would mean it would extend to 4.2 meters. Alright, whatever the original length is. Let's say if the original length is 10 meters for both of the springs, this would extend to a 4.2 meters. Let's see, if I am talking about this, for the same force, if I use the formula, 10 is equals to the stiffness is 1.4 times E. So E is equals to 10 divided by 1.4. So this would give me something like approximately around 7, something like that, right? 7 for the 28. So 2, 7, 7, 9.8. Yes, it would give me approximately around 7 meters. I don't have a calculator right now, so I'm just approximating some values. So you can see that this spring with the lesser stiffness gives me more extension, obviously because it's a softer spring, as we predicted, compared to this one, which is a stiffer spring because it has a greater stiffness. So that is why it's difficult for me to extend it. This simply, for this case, it simply means, I mean, if you can analyze it, it simply means that you need 2.3 newtons for every meter. You need 2.3 newtons. You can just see the units. It's simply that is what it means. 2.3 newtons for every meter you need to extend. So if you need to extend it by 1 meter, you need 2.3 newtons. So since you are applying 10 newtons, so just divide this by 10 and you will see how many meters it will extend. However, if you talk about this one, in this case, you need 1.4 newtons for every meter. So if you want to increase it by 1 meter, you need 1.4 newtons. So this makes it a softer spring. So before you even start calculating, you should know how to predict some of the values. You should just look at a spring, look at the value of the stiffness of the spring, and you should be able to tell that which of the two springs would be a softer spring. So I hope you understood this. We'll be doing some more examples and some more understanding in the next lectures. So thanks for watching, guys. Stay tuned to it.